Hi everyone, hope you are following the lessons regularly. Okay, and reading the textbook thoroughly. Okay. Now, in the last session, we were dealing with what do these acids and bases have in common, isn't it? That means we have done an experiment with some substances like HCl, HNO3, H2SO4. You are remembering? You have done an activity HCl, HNO3 or sulfuric acid along with the glucose. Are you remembering? C6H12O6 or an acid, an alcohol. Okay, for example, CH3OH. Okay, we have done the experiment and what was the result? The result was in all this, that is HCl, HNO3 and H2SO4, when we bring a circuit and in a bulb in it, the bulb glows, isn't it? The bulb glows, which means that electricity is passing through the circuit. Okay, now how the electricity is passed, we know in solution. You are making this solution of HCl, isn't it? Dilute solution of HCl, HNO3, H2SO4, sugar solution as well as glucose solution or alcohol solution. All are solutions. Okay. Now the bulb glows means electricity is passed through it, and who are the carriers of electricity or current in solution? It's very important. Who are the carriers? Ions are the carriers, isn't it? So it's very important. Ions are the carriers of electricity or current in a solution. Whereas in a metallic conductor means in metals, who is responsible for the conduction? You have studied metals are good conductors of electricity and heat. Now, who is responsible for conducting in metal? Electrons, isn't it? That's why we call electronic conductors. Now, in solutions, who is responsible? Ions are responsible for conducting the current in solution. So, there I told you the H plus ions, because you see, what was the definition we have given for an acid? Acid means any substance which can furnish H plus ions in solution, isn't it? What is it? The substance which can furnish or which can give H plus ions in solution. So I stress the point in solution. Okay. Now why I stress the point? That is in solution. So H plus ions, a substance which can furnish H plus ions in solution. So I am stressing the point in solution. So what does this mean? This means that H plus ion or a substance can be said to be an acid only in presence of a solution. What do you mean by that? How can H plus ion behaves as an acid in a solution? Well, for that you have an activity in your textbook. Okay. Now, in case of base, in base, who is responsible for the conduction of electricity? OH minus ions, isn't it? Base means a substance which can able to furnish or which can able to give OH minus ions is called as a base. Okay, there are so many types of base that we will study later, but for your this thing, OH minus, anything which can furnish OH minus ions in solution. So here also there is no C, ions. OH minus ion is an ion, correct? But this radical is an ion. So these ions are responsible for conduction of electricity. Clear? So now, why I stressed this H plus ions or OH minus ions in solution, you call it as an acid or a base. Okay. For that, we will have an experiment or an activity in your textbook. Okay. What is that activity we will see. Now, in that activity it says, if you take a dry test tube, okay, in a test tube holder or in your hand, it is better to be in a holder. Okay, it is better to be in a holder. Then you add solid NaCl. What do you add? You add, you know, solid NaCl is what? Salt, table salt, isn't it? So you add solid NaCl crystals, solid NaCl in this test tube. Okay. So you have added what? You have added NaCl crystals, which is in a solid state. Correct? Now what you should add is, you add concentrated H2SO4. What is that? Concentrated H2SO4 means what? There is no water molecules in that, isn't it? When we dilute it, we add water molecules in it. So concentrated sulfuric acid. So while doing in the lab, you are very, very attentive while doing this or while handling this concentrated acid, because it is very fuming in nature. Okay, so gas will come. Okay. So you add concentrated H2SO4 very, very slowly and very attentively to the sides of this test tube. So I am adding what? Concentrated H2SO4 in this test tube. So I am adding it to the sides of the test tube. So then NaCl react with the H2SO4. Okay. Now what you will do is, you have a cork. Okay. Then here there is a delivery tube here. Correct? Delivery tube in which some gases are coming. Okay. Now what is the experimental part? Take a dry test tube. There also I mentioned dry test tube. Why? Because there must be no water molecules or humidity or parts of water in that. We need a dry test tube. Okay. Then you add sodium chloride crystals in it. Then you add what? Concentrated sulfuric acid. I said concentrated. Okay. Concentrated sulfuric acid into it. Drop by drop to the sides of a test tube. Be very careful in handling this concentrated acids. Now, then what happened? Then through the delivery tube, some gas is coming. So what will be the gas? If you see the equation for this, we will say NaCl. Okay, we will say NaCl plus concentrated H2SO4. Correct? Concentrated H2SO4. You will get what? You will get NaSO4 plus HCl. See? What is getting? NaCl plus concentrated H2SO4 will give you NaSO4. So if you say to you can't write NaSO4. Can't we? No, because the balancing -2 plus 1. So you have to write Na2SO4. So for balancing you have to put 2 here. You know that. Okay. So Na2SO4 plus 2HCl. Now listen carefully. What is this? This is HCl means what? HCl means hydrogen chloride is getting in the gaseous form. Correct? Now in this equation, or when this chemical reaction happens, what you will get the product as? A salt which is soluble. So you see in the experiment there is some liquid here and some gases are coming. Okay, now we want to check that gas. Okay, so this gas is nothing but HCl gas. Remember, this is a gas, and now the test is you have to see whether this shows acidic behavior. What is it? This HCl gas, we say HCl, that is hydrochloric acid, is acidic in nature, isn't it? But here you got HCl gas. Now we want to know whether this HCl gas shows acidic behavior. Now tell me, what is the definition for an acid we given? That is a substance which provides H plus ions in solution. Correct? H plus ion in solution. Correct? Now what we will do is, we take a litmus paper. Which litmus paper you have to take for testing an acid? Which litmus paper you have to take for testing an acid? Yes, blue litmus paper. Now what is observation? When acid turns the blue litmus to red litmus paper. I mean the blue litmus to red, or the color will change from blue to red if it is an acid. If it is a base, the reverse happens. That is red. The color changes from red to blue. Now here what has to happen? Now we are having two things. Okay, let me change this. Now we have two things. We have taken one. I took one dry litmus paper, listen very carefully, and second I took moist litmus paper. Okay, what do you mean by moist litmus paper? I dipped it in water. Correct? I dipped it in water and I took that litmus paper. So that was the experimental part. Okay. Now what happens is, now I show this, first I show this blue litmus paper, okay, dry blue litmus paper at the mouth of this delivery tube. Listen, I showed the dry blue litmus paper, okay, dry blue litmus paper at the mouth of the delivery tube. And you know, when this reaction happens, which is the gas evolved? HCl gas is evolved through this delivery tube. Now, what happens if this is an acid or this HCl gas shows an acidic behavior? What should be the color change of this blue litmus? It must change this blue color to red, isn't it? That is the concept. Okay, but when we show a dry blue litmus paper into the mouth of this delivery tube, the observation was no change happened. That is, the blue color remains as such, or the blue color is not changing into red, which means that the HCl gas evolved in this reaction is not showing the acidic behavior. Got it? The HCl gas which is coming through this delivery tube is not showing acidic behavior when we show a dry blue litmus paper at the mouth of this tube. Got it? Clear? Now, when I change this dry litmus paper into moist litmus paper means I dipped it in water and showed into the mouth of this HCl gas, the observation was this blue litmus changes to red. See? This blue litmus changes to red. What does that mean? Which means now this HCl gas shows acidic property. Correct? Then only this blue litmus can change to red. Isn't it? When we say that the blue litmus changes to red, when a substance is acidic in nature, isn't it? So then we can say that the inference or the result is, the observation is the moist blue litmus paper changes to red, which means this HCl shows an acidic behavior. Now the question is, why the first part or with the dry blue litmus paper, why the HCl gas does not show the acidic property? Isn't it? So the question is, why in the first case the HCl does not show the acidic property? Okay. Which means that I have said in the earlier session, an acid is a substance which can furnish H+ ions in solution. Isn't it? Which means what? In the first case, what was it? Let me rub this. Okay. In the first case, what was happening? In the first case, the HCl gas plus dry litmus paper was there, isn't it? So, dry litmus paper means what? There is no water in it, isn't it? But in the second case, so there is no reaction, correct? But in the second case, this HCl gas react with this water in the litmus paper. Very, very carefully listen. This is the concept. That is, the HCl gas which is produced in the delivery tube or past the delivery tube, when a moist blue litmus paper is shown, it reacts with the water. That means water is a liquid, correct? Liquid to form, what is it? H3O positive plus H3O positive, isn't it? H3O positive plus Cl minus. See, it's very, very important. That means when HCl gas react with the water molecule, the water, liquid water, the moist litmus paper, blue litmus paper, what is formed? See, ions are formed. What is that? Ions are formed. That is plus ion as well as the minus ion. Which means only in presence of water, listen, only in presence of water, the HCl gas which you call it as an acid, dissociates into H plus and Cl minus. Listen, only or in absence of water, that is in the case of dry litmus, the HCl does not dissociate. You know what is dissociate? Yeah, that is dissociate into H plus and Cl minus. No. Only in the presence of water, the HCl gas dissociate into H plus and Cl minus. See, here you can only write H plus aqueous. See, H plus aqueous. Why? Why? Because, see, this dissociate to form H plus and Cl minus, isn't it? This H plus HCl dissociate to form H plus and Cl minus. Correct. Now what happens? This H plus cannot stand independently, or it cannot exist independently. You will say this as a proton in structure of atom. Okay, here you will say H plus ion. Okay, so this H plus ion cannot exist independently. It has to bind with something else. Okay, so what it will do? It will, this H plus ion combines with this water, see, water to form H3O positive. See, what is it? H3, H2 plus H, that is H3O, that is O and the positive charge. In fact, this is H plus. This H3O positive is also written as simply, what is it? H plus aqueous. Remember very carefully. Simply putting H plus, no, it is wrong. You have to write this phase, that is aqueous. Or, that means I will say, listen, I will say H plus, that is H plus aqueous is equivalent to what? Is equivalent to this H3O positive. You can write either H plus aqueous or you can write this H3O positive. Now, what is this H3O positive called? It is called as hydronium ion. What is it? Hydronium ion. This H3O positive is called as, what is it? Hydronium. Okay, hydronium ion. This H3O positive is called as hydronium ion. So, what is the funda of this? This reaction says that, or this experiment says that, what? That is, the H plus ion cannot exist independently. That means it binds with this water molecule to form this H plus as well as the Cl minus. Correct? Or H3O positive plus, H3O positive plus Cl minus. Then that H plus behaves as an acidic character. Now you got it. Why? If you show the moist blue litmus paper, the litmus color changes from blue to red. Why? Due to the formation of H plus ion. That is the value point. What is it? Due to the formation of H plus ions. Now where from this H plus ion is getting? This H plus ion is getting from the reaction with water. That's also important. This H plus ion cannot exist independently if it dissociates. Dissociate means changing, completely changing. H plus and Cl minus. Okay, so that is the thing. So it exists as hydronium ion. Okay, now you got the point or the answer why I stressed in solution. That is, any substance which can furnish H plus ions or OH minus ions in solution. You have got the answer, right? Yes. Okay, so that is the explanation for this activity or experiment. Okay, now what you should do? You should write this experiment in the notebook with three things. What is it? Experimental part, observation part and the result or the inference part. Okay. Now there is one more thing that they are telling. If you are doing this experiment in a humid situation. What is humid? That means the water vapor. The content of water vapor, the percentage of water vapor is excess in the atmosphere. That means what? There is water molecules present in the atmosphere. That is humid, isn't it? We have studied in 9th standard humidity. Okay. So, if this experiment is taking place in a humid place, what will you do? If you if you take the not the wet, the dry litmus paper also, if the atmosphere is humid, water vapor is there, it will automatically becomes what? Moist. So what you have to do in that case is, what you have to do? You have to take calcium chloride. Why you take calcium chloride? You have to take a guard cell in this test tube. You have to give a test tube and there is a delivery tube, right? In the delivery tube, you put a guard cell. Guard cell means a small thing, what is it? Like this, a cell type structure in which you put calcium chloride into that. Calcium chloride crystal into that. Now, what is the role of this calcium chloride? This calcium chloride is deliquescent in nature. What's deliquescent? What is deliquescent in nature? Have you heard about deliquescent and efflorescent? Deliquescent means deliquescent. Okay, what is deliquescent? Deliquescent means calcium chloride acts as a deliquescent, which means it absorbs the moisture and dry HCl gases passed into it. Correct? It absorbs the moisture, then dry HCl gases passed into it. Therefore, you can have the experiment or you can get the experiment correctly. Okay, so that is another part of doing the experiments. Okay, while doing the experiments only we come in all these proportions. Okay, so that's okay. Now, so calcium chloride is used as a deliquescent. So that is all about the activity. So again I am saying, what is an acid or a base? An acid or a base is substances which can furnish H plus ion or OH minus ion in solution. Okay. Now, the equation was what? The equation was, I will again write, HCl plus H2O will give you H3O positive plus Cl minus. Correct? This is aqueous. That is aqueous. Okay. This is liquid. Okay. In the same way, now you got this. Correct? Now in the same way, what happens when a base reacts with water? What happens when a base reacts with water? Now tell me, what is a base? Shall I rub this? Okay. What is a base? You are studying acid base, isn't it? Now what is a base? You know, a base is something which can produce OH minus ions in solutions, isn't it? OH minus ions. Example for a base. Example is NaOH. What is NaOH? NaOH is sodium hydroxide. Why you put sodium hydroxide? -1 plus 1. So it is sodium hydroxide. Or tell me another base. Another base is potassium hydroxide. Okay. And another one, calcium hydroxide. So all these are the examples of what? Bases, which can furnish OH minus ions in this solution. Correct? Now what happens is, what is the reaction of this base with water? What? The acid plus water, you get what? The ions, H plus and H plus aqueous plus OH, Cl minus ions, isn't it? That is HCl. H2SO4 means H plus aqueous and SO4 2 minus. Now in the same way, what is the reaction between this base and water? Okay, now what is the reaction? If you take NaOH as the base, okay, NaOH is a strong base. Now, when it reacts with water, when you put it in water, you will get what? Na plus and OH minus. See, again the ions are there. That is why we say in solution. Got it? So, the ions are getting. So, Na plus and OH minus ion. And this OH minus ion makes the solution basic. Correct? So, the ions are producing. That is Na plus and OH minus ions. Okay. Another example. If you want another example, KOH. KOH you will get with what all ions? K plus and OH minus. See, OH minus ion is produced. In acid, H plus ions are produced. Base, OH minus ion is produced. Again, more examples, magnesium hydroxide, calcium hydroxide, etc. Now you got it? So that is why we say the ions in solution. Then only we can say a given substance is an acid or a base. Clear? Understood? Okay. Now, one more thing about the base is, bases has many, like simple base, okay, complex, etc. But one other classification is, you can classify this base as soluble base as well as insoluble bases. See, a simple classification of bases are soluble bases and insoluble bases. Now, what do you mean by soluble base? Soluble means what? Something gets dissolved, isn't it? For example, if you take some water and sugar in it, if you stir it, what will happen? The sugar is getting dissolved in it, which means the final solution is a single solution, or I can say a homogeneous solution, correct? The concentration is same throughout. In the same way, solubility means something is dissolved in it. So, soluble bases as well as insoluble bases. So, soluble bases means it dissolves in water, and insoluble bases means it is not dissolved in water. Correct? Okay. Now, in the soluble bases examples, we studied NaOH, KOH, then magnesium hydroxide, calcium hydroxide, etc. Correct? Insoluble bases are, for example, just for information, lead hydroxide, then zinc hydroxide, something like that. Okay. Now, there is a peculiarity for soluble bases. You call these soluble bases as alkalis. See, what do you call these soluble bases as? You call these soluble bases as alkalis. Okay, so bases can be classified into soluble and insoluble. Now, what you call soluble bases? Soluble bases are called as alkalis. Or, how will you define an alkali? How will you define an alkali? That is, bases which dissolves in water are called alkalis. Correct. You will study in the 5th chapter periodic table. You will just study the first group elements like lithium, sodium, potassium are all alkali. Okay, that is why they are called as alkali metals. Correct. We will study it later. Okay, so now here soluble bases are called alkalis. Okay, insoluble means it is not soluble. Lead hydroxide can be soluble in hot water. Okay, that you will study in later classes. Okay, so now you have defined alkalis. Now there is a board question here. The question is, listen, the question is, all alkalis are bases. Listen carefully. All alkalis are bases, but all bases are not alkalis. Got it? Just write down the question. That's a homework. That is, all alkalis are bases, but not all bases are alkalis. Okay, just comment on that. It's a homework. Okay, so what are alkalis? Water. In one word I can say what is alkali. Alkali is water soluble bases are called alkalis. Correct? Water soluble alkalis are called what? Bases. Sorry, water soluble bases are called alkalis. Now you have NaOH pellets. You say pellets. Sodium hydroxide pellets. Okay. If you mix it water, it will have a soapy touch. Soapy means what? Yeah, you know what is soapy touch. Okay, so we can say the property of base here. There are three properties in this alkali. That is, it is having a soapy touch. Okay, now what are bases? The properties of bases? That is bitter, isn't it? Bitter in taste. And third is, it is corrosive. Okay. These three are the properties of bases. Just like acids we said, isn't it? It is sour, it is not soapy, and it is corrosive. Yes, it's also corrosive. Acids are also corrosive. Okay. So these are the topic which is acid bases when treated with water. It's very, very important. This is a concept where you can call which substance as an acid or which substance as a base. You can't call, for example, I will say C6H12O6. Okay, or if you take CH3OH, in all these, this is organic substance, in all these cases there are H+, which doesn't mean that it acts as an acid. Understood? Okay, so an acid means which is capable of furnishing the H+ ion. This is not capable of furnishing H+ ion. Even this is not, to some extent studied organic, that's a different story. But it cannot furnish or it cannot act as an acid. That's it. Okay. So that's all about this reaction of this water with the acid and bases, which gives ions in solution, which make it possible for the conduction of electricity. Hope you understood clearly. Okay. Now you know the neutralization reaction. Coming back again to neutralization reaction. Okay. Coming back again to neutralization reaction. What is neutralization reaction? That is, an acid plus base gives salt plus water. Okay. Now I can write an acid plus base. An acid plus base gives salt plus water. Now you know acid contains H plus, base contains OH minus. These two will react to form water. So that is why we get water here. Okay. Now in generally I can write it as, see, HX, because H is for the acidic character, and plus MOH, that is OH is for the basic character. Generalized equation for a neutralization reaction. Okay. Now HX means you are saying it's an acid because it has got an H plus, and MOH, because why base I wrote MOH, M is always a metal. Isn't it? Metallic oxides are basic in nature. When that oxide dissolves in acid, will give you the hydroxide. Isn't it? This in the third lesson you have studied. Okay, with water. Now, HX plus MOH will give you, you know, this H and this OH will give you what? This H2O plus MX, that is the salt. So, this is the generalized equation for the neutralization reaction. Correct? If you want an example, HCl plus NaOH. The very good example is NaCl plus H2O. A simple example, always for the neutralization reaction, a salt plus acid giving, an acid plus base giving salt plus water. So understood? Now we will pass on to the next topic, which is also very important, that is how you dilute an acid, or how you dilute an acid with water, or how you will add water into an acid. That is dilution, right? We have a concentrated acid. How will you dilute it? You add water. Okay. Now the problem is, see, listen. You have a test tube with concentrated acid. Be very careful in handling. You won't have to do it. The lab teachers will do for you. You have a concentrated acid in a test tube. Maybe sulfuric or a hydrochloric acid. And you have a water in a beaker. What do you have? You have a test tube having concentrated acid, okay, concentrated HCl, and you have a beaker with the water. Okay, now what you want to do? You have to dilute or dilution. You are calling it as a dilution process. Okay. Now there are two options for you. What are the two options? Either you pour this acid into water, or the water into acid. Correct. Two options. One, either you put this acid into water, you can dilute it, or you can pour this water into the acid, then again dilution happens. But what is the correct option? What is the correct option? Either I want to put this acid into water, or water into acid. That is called as dilution. Okay. Now we will see what happens when we put acid into water or water into acid. See. Now, generally, on dilution, or if you want to dilute a concentrated acid, you should pour the acid into water with constant stirring and slowly. Two things. You have to pour this acid very slowly into water, and doing it, you have to stir with a stirrer in the solution. Two value points. Okay. So, we will see that. Okay. Now, I have this water. Okay. Now, the concept is what? You have to add the acid into water and not water into acid. We will explain why you don't dilute by putting water into acid. Okay. Now, what you have to do? You have to take the concentrated HCl. Now, you have to take the beaker having water. Then what we will do? You slowly pour this HCl very slowly into this water with constant stirring. with constant stirring. So slowly, okay, slowly and with the two value points are there, slowly as well as constant stirring. So 2 points, slowly and constant stirring. Now what is the use of this constant stirring? Why you want to stir it? Now if you pour this into this, if you put your your hand or if you touch the beaker, what you feel is, you will feel hotness or warmth, which means what? Which means this reaction is an exothermic reaction, isn't it? What is exothermic reaction? A reaction in which the heat is liberated, isn't it? In the chemical reaction is called as exothermic. So if you put or if you touch the beaker, you will feel a warmth or hotness, which says that this reaction is what? Exothermic in nature. What is it? Exothermic in nature. So that is the reason why you have to pour very, very slowly. Because what happens? At once you pour in one bulk, being an exothermic reaction, what will happen? It will splash out, isn't it? The whole solution gets splashed out from the beaker, and what happens? It will cause burns, isn't it, for us? The burns in the skin, or it will splash out into our body. So that is the reason we have said you have to pour it very, very slowly. Got the point? Now the second point is, why you want a constant stirring in that? Why? Because in order to delocalize the heat, it's very, very important value point, that is for the delocalization of heat or for delocalized heat. What do you mean by delocalization of heat? See, if you pour this HCl at once, what will happen? If you are not stirring with a stirrer, and the HCl is poured into one direction, it is here, accumulating here, it is an exothermic reaction. The heat will be very, very high, isn't it? Because it is a concentrated acid. So what happens? In order to keep the heat, this is localized heating in one point. So in order to have this heat into equal distance, that is delocalization. Okay, for that you have to stir it. That is, we are getting the heat in all the directions so that the heat is not getting into one point, which makes it very, very dangerous. It will get splashed out and burns can happen. Severe burns can happen. Okay, so that is why for delocalizing the heat or delocalization of heat, you have to constant stir. Correct? So this is why, that is why you have to pour an acid into water and not water into acid. What will happen if I have a test tube full of or a beaker full of concentrated acid, and if you pour water into it, what will happen? It will burn out. Isn't it? It will get splashed out. And at the same time, there is also one more possibility. If it is a localized heat, if you are not stirring it, what will happen? There is a chance of breaking this beaker due to the high amount of the liberation of heat. Okay, so the funda is, what is it? You have to always add an acid into water and not a water into an acid. Got it? So that is what is called as dilution. Now what is dilution? Dilution is nothing but the mixing of an acid, or the same happens in base also, sodium hydroxide pellets. When it is react with water, exothermic. So dilution means mixing up of an acid or a base with water. That is acid. Okay. Then one more thing, in the value point in dilution, one more thing is, that is the decrease in the ions. What is the ions? That is decrease in the ions. Okay, decrease in the ions per unit volume. This is the correct definition for dilution. That is, mixing up of acid or bases with water in order to decrease in the ions per unit volume is called as dilution. That is, the concentration of the H plus ions or the OH minus ions is decreased in the unit volume. How you go for that? In unit volume, how you say decrease in volume? Say for example, you have a beaker and assume that in this unit volume, if you say there are 5 H plus ions, okay, 5 H plus ions are there. Now what happens if you add water into it or a dilution? You are making the volume bigger, isn't it? Now what happens? There is a chance of what? This hydrogen ions to go around, and after dilution you can see only one. Maybe there is only 2 ions instead of what? 5 ions, because there is an increase in volume. So the ions are getting far apart. So that is where you call a dilution. That is, the number of hydrogen ions or OH minus ions decreases per unit volume. Then you will call it as a dilution. Understood? So today we studied what the concept of what is an acid, what is a base. Now when we say an acid is substance which can furnish H plus ions or OH minus ions in solution, that's the value point. Remember. Okay. Then how you dilute an acid. Very, very important. Okay. So please read the book thoroughly. Get a note of it. And if any problem is there, call me. Thank you.